No,
We have developed the software in MATLAB. No, no, sir. All the equations we have given in the full paper, all the equations we have implemented, we have deployed on software in MATLAB. Yes, sir.
so one of the main objectives is to strike a trade-off between the visual saliency method which I had shown before and the energy-based method which is seam carving. Now seam carving is low computation cost. It takes up to only about 5 or 6 seconds to compute the whole energy image, compute the seams and remove the seams. However, the visual saliency methods involve a lot of pattern recognition. You need to actually identify where the humans are, which are the important objects in the image, and their relative sizes, their relative distances, and go to the previous slides. Very first. Yeah, this one. Yeah. So you can see here clearly that the humans in the background, they are not identified as objects. That means the object detection has been very strict as long as these three objects, that these two boys and the football is concerned. So according to the reference from which we try to, we are trying to solve this problem, and this reference claims that they took up to 40 minutes just to identify the segments, and they say that 40 minutes itself is an improvement in as far as the resizing the images is concerned. So we can definitely say that if you want to resize images using the saliency preservation method, we have a high computation cost, and our method is fuzzy logic based image resizing. So in fuzzy logic we do not take statistical analysis of each pixel separately. What we have done is
Actually, what we do, first we do subtractive clustering to predict the number of clusters. Pixels, all the pixels of the image are given as input, and it just predicts that what may be the number of clusters. We give it to fuzzy Siemens algorithm. First we optimize it based on the closeness of all the clusters or intensity difference. We optimize, we converge into two regions into one if the intensity difference is less. Then we give it to fuzzy Siemens, which gives belongingness of each pixel to. It's not classified that this pixel belongs to this region. It only gives belongingness of value between 0 to 1, like it's 0.6 in region 1, 0.4 in region 2. So then after fuzzy Siemens, we have just three simple membership function which classifies separately that this pixel belong to which region. Now all this fuzzy image segmentation is very low computation cost, and even if we decrease the number of clusters, because after decreasing the number of clusters, we have a poor segmentation. Relatively poor segmentation. But even it suffices for seam carving. That's why we are saying that it's low computation.
The
Percentage of accuracy.
Okay, we have defined the percentage of accuracy as the number of, the reason why we followed RGB and HSV was basically to show that the number of skin pixels, or you can say the number of non-skin pixels which have been classified as skin. So that was very high when we used only RGB or HSV separately. But this was nearly like, as you can see here, we have not done a statistical analysis of the percentage of accuracy, but visually showing you, and we can also show you other images where we have obtained reasonably accurate results for skin detection. Here, the hand and the 4 faces have been identified as skin regions.
Yes, sir.
Yeah.
Yes.
Yeah. Again, like I said, the certain regions are, like for example, the color of the tiger and the man, the clothing he is wearing is nearly equal to the skin color, and it is neither brown nor red. So, of course, color segmentation has never been achieved completely, and our main motive is not to achieve accuracy in segmentation and color segmentation and image segmentation, dividing up the image into the regions. We just want to show that even though these are poor, like as you can see, this is not a very accurate segmentation result. Even though these are poor, when we combine to get a new weight matrix, and add it to the energy function. Seam carving is a greedy algorithm, so it computes the weight from top to bottom and then resizes by removing the low cost seam. So since it's a greedy algorithm, such very less pattern recognition and very less color segmentation is sufficient for the entire protection of the image. You could have also seen the poster that the picture with the beach, people on the beach, the segmentation was very poor and one person was actually not detected as having skin. But however, we still obtained a good result as the resized image. Yes. Yes. Of course, yes, sir. We did obtain a bad result. The problem is we are detecting skin. I'll give you the reasons why we obtained bad results, sir. Yeah. Yeah. Of course, we have it on our computer. We can show it to you after the yes. Yeah, it was basically a person, basically a very sort of a marketplace in the background, and a lady standing in the front, and she was covered up completely except for her face. So what happens is her clothing was, she was kind of from a, you can say, a traditional dress, and her clothing was very colorful. So every portion of her dress was defined, identified as a different segment. So what happened in that case was, since it identified a different segment and her face stood out well, so only the weights in the face region got increased, and the seams passed. They were able to protect up to her torso, and beyond which her legs were slightly cut. So we could say that the next step for obtaining better results is to identify the human as a whole using a fuzzy logic method. So that could be a future direction. Any other questions? Yeah, this can be implemented.
In that case, there won't be any human beings, so only the seam carving part will work and no extra weights will be added. So
the skin detected will be completely random because there are no skin pixels. It will be completely random, so weights will be randomly allotted, so preprocessor will not have any effect. So it's an automatic method, nevertheless.
Any more questions?
Thank you.
Thank you.
Thank you.
Thank you, sir.
Sir M. Visvesvara Institute of Technology, Bangalore is next, and the topic is design of multi-purpose nanobullet.